Hello, grade 12 students. In this video, we will be solving exercise 7. It contains many ideas that will be important for the exam and for the other exercises that we will solve in class. Okay, so they gave us two functions, f and g, defined on this interval, 0 plus infinity. And they gave us a line D of equation y equal x. The first part is to set up the table of variation of g. Okay, so as you can see, g here is this function. Okay, I have to find the domain of the table of variation of g. First, the domain of definition is 0 plus infinity, so I put 0 here and plus infinity here. Let's find the derivative. G prime, the derivative of 2x, of x squared is 2x. The derivative of ln x is 1 over x. And we know that here x belongs to this interval, 0 plus infinity. So 2x has to be positive, and the same here, x is also positive. So the whole thing, g prime, as a whole is positive because here x is positive. If g prime is positive, then g is increasing. I still have to put a value here and the value here. They are the limits. We can also easily calculate the limits. As x goes to plus infinity, okay, we will have x squared will go to plus infinity, and the same happens with ln x. They both go to plus infinity. So we have a plus infinity here. And when x goes to 0 plus, then x squared will be 0, and ln x, as x goes to 0 plus, it will be minus infinity. Okay, هاخدناها بالproperties. So this will be the table of variation of g. For the second part, show that the equation g of x equals 0 has a unique root k, and find a framing of k of amplitude 0.1. Okay, يعني مثلا between 0.9 and 1, between 1.5 and 1.6. So هيك يعني amplitude 0.1. From the first lesson we took this year, نعرف إنه g of x equals 0 has a unique root عندها بس تكون continuous و changes sign in a given interval. نعرف إنه عندها root إذا كانت strictly monotone, يعني strictly increasing أو strictly decreasing, then it have a unique root. Okay, so here in part 2, we know that g is continuous on 0 plus infinity because it's increasing. G changes sign. Okay, as you can notice here, it is a negative, and then here it becomes a positive. And then g is strictly increasing on 0 plus infinity. These three conditions, we can conclude from them that g of x equals 0 has unique root k on 0 plus infinity. Okay. They also asked for a framing for the root. Okay. We start by picking any number. Okay. For example, g of 1, it's an easy number. We cannot pick g of 0 because g of 0 is not defined. Okay. G is not defined at 0. It is open at 0. So we cannot find g of 0. G of 1 was equal to 1. So it is positive. We are just substituting 1 in the equation of g. Okay, so we tried a number less than 1. Okay, we tried a number less than 1. Why? Because as you can see, g is increasing. Okay, for example, إذا جربنا ال1 وطلع الانسر هون كمان 1. Okay, نحن منا root، يعني منا الانسر هون يكون 0. So I have to pick a number less than 1. Okay, مش greater than 1. هون ما بيهموني النمبرز. Okay, so I tried g of 0.5 and I get a negative number, minus 0.44. So I have to try again. G of 0.6 is also negative. I tried g of 0.7 and it came out to be positive. Okay, so the root must be somewhere here. Okay, so if we have a number line, for example, okay, if we have a number line at 0 here, the domain of definition starts at 0. Okay, at 1, it was somewhere here, it is positive. Okay, it is above the x-axis here. At 0.5, it was negative. Okay, so I searched for something here. At 0.6, it was also negative. And at 0.7, it was positive. And the curve is something like this. Okay, at 0.6, can negative. At 0.7, can positive. Okay, that's why the root is somewhere between 0.6 and 0.7, and this interval 0.6 0.7 has an amplitude of 0.1. Okay, so now let's continue. For part 3, we have to precise the sign of g of x. Okay, here we know that g of x is increasing. Okay, at this root k, we do not know the value of k exactly. We know that it is somewhere between 0.6 and 0.7. Maybe it's 0.61, 0.65, whatsoever. At k here, okay, we know that g is equal to 0. So when x is greater than k, g becomes positive, and when x is less than k, g becomes negative. Okay, why? Because it crosses the x-axis at k. Is عندنا drawing, for example. Okay, راح يكون عندنا الk هون. Okay, the curve is increasing, passes through k, and also keeps on increasing. It's positive after k and negative before k. Okay, so before this root, before k, yani between 0 and k, g of x was negative, yani below the x-axis. At x equal k exactly, g is equal to 0 because it is a root. K is a root, so g of x is equal to 0 at k. And after k, from k to plus infinity, g becomes positive. Okay, we can write the answer like this, or we can write it in the form of a table. Okay, for example, x goes from 0 to infinity. This is the domain of definition. Okay, at k it is 0, before k it is negative, and after k it is positive. Okay, now for part 4, they asked us to study, according to the values of x, the position of c with respect to d. D is the line of equation y equal x. Okay, as we can see here, I called them, they are written in the question. And c is the curve of equation f of x equal this function. Okay, so to find the relative position of two curves, okay, let's say we have the function f of x and the function g of x. Okay, so let's say we have f of x and g of x. Sorry, the connection is not very well today, so you'll be hearing that so much cuts. Okay, f of x minus g of x. If we subtracted both these functions and we get a positive answer, it means that f is greater than g. Okay, so the curve of f is higher than the curve of g. Okay, and if this, when this is equal to 0, means both curves intersect. بصير عندنا f equal g. And if this is negative, شو معناتها؟ معناتها f is less than g. So the curve of f is below, okay, the curve of g. Okay, great. So here we have to find the difference between f of x and yd. Okay, this the equation of the line d is simply y equal x. Okay, so we subtracted f minus y. This is f over here minus, and the equation of the line d, which is only x, So we had this answer, this fraction. What do we know about this fraction? We know that x belongs to 0 plus infinity. Okay, the domain of definition is 0 plus infinity. So x here is always positive. And we have the minus sign over here. So I can write this fraction as follows. I can write it as ln x plus 1 all over minus x. Now we guaranteed that the denominator is what now? X is positive, so minus x is negative. هذا شو صار نعرف؟ بنجيب sign للنumerator. If the sign of the numerator كانت positive, معناتها all the fraction is what? Negative. لا لأنه positive over negative is negative. And if the numerator was negative, then we will have a negative over a negative, which is a positive. Okay, so now we have to study the sign of ln x plus 1. Let's see first, when is ln x plus 1 equal to 0? Okay, ln x plus 1 is equal to 0. We take plus 1 to the other side, we'll have minus 1. Okay, we know that we can write minus 1 as ln e to the power minus 1. Okay, we can do this in fact for any number. A is equal to ln e to the power a. Okay, so instead of minus 1, I put ln e to the power minus 1, and I get what? I get that ln x now. Okay, so ln x is equal to this ln. It means that x is equal to e to the power minus 1. E to the power minus 1 is simply 1 over e. Okay, so now what happens before e to the power minus 1 in e? We know now when it is 0. Okay, we know that f x minus y is equal to 0 when x is equal to e minus 1. Okay, but when is it negative and when is it positive? To know this, I can try instead of x any number greater, for example, than e minus 1. Okay, e minus 1 and هي 1 over e. Okay, يعني she 1 over 2.7. Okay, يعني أكيد هي less than 1. Okay, so I can try, let's try for example the number 1. Okay, let's try to substitute x equal to 1. What will we get? We will get ln 1. Okay, ln 1 plus 1. And we will have this. Okay, ln 1 plus 1 over minus 1. This is equal to 0 plus 1 over minus 1, which is minus 1. Okay, so it is a negative. لما الx كانت 1, we got a negative answer. شو معناتها الx is equal to 1؟ شو قلنا هي greater than 1 over e. Okay, so مشان هيك فينا نجي على هاي الكونكلوجن إنه when x is greater than e to the power minus 1 راح يطلع الجواب عندنا negative. مثل ما هون شفنا لما الx كانت greater than 1 over e شو طلع الجواب؟ negative. اوكي، واكيد فينا نحلها بطريقه ثانيه، فينا هودي نعملهم ترايلز ويطلع معنا الجواب، او فينا مثل ما حلينا الايكوال تو 0 نيجي نحل الباقيين. يعني okay, let's erase these. مثل ما حلينا هاي هي z، بس نكتب مثلا ln x plus 1. for example 1 is this positive. This is positive لما تكون ln x is greater than minus 1, which is equal to ln e to the power minus 1. ln greater than ln معناتها x is greater than e to the power minus 1. okay, لكن هاي بتطلع positive لما x تكون greater than 1 over e. بس again ما بدنا ننسى انه اذا هيدا numerator كان positive و denominator شو عندنا اياه negative. numerator is positive, denominator is negative, and the fraction as a whole is negative. okay, مشان هيك حطينا هاي الفراكشن as a whole is negative لما x تكون greater than e minus 1 يلي هي طلع معنا. Okay. Now let's continue. بعد ما جبنا relative position الساين حطيناهم بتيبل، اسهل نكتب relative position. قلنا إذا طلع الديفرنس بيناتهم positive معناتها ال F أكبر. ف the curve C of F is what is above D. ولما يطلع negative بيكون the curve C is below the line D. And of course when it is equal to 0 then they intersect each other. C and D intersect. Okay, the part after that they asked us to find these limits and interpret the results. Okay, so first limit f of x as x tends to 0 and x is greater than 0 يعني x كأنه tends to 0 plus. هيدا الاف حطيناها بقيمتها، عوضنا الاكس 0، شو راح يصير عندنا هون؟ راح يصير عندنا 0 minus ln 0 plus is minus infinity plus 1 حد الانفينيتي ما لها طعمه، ف over 0 plus. هاو بدنا ننتبه لهم منيح انه هيدي منا indeterminate form. Infinity over 0 is infinity. Minus times minus is plus، راح يصير عندنا جواب plus infinity. Okay. Limit لكان as x tends to 0 طلعت plus infinity. What can we deduce? How can we interpret this result? We know that the line of equation x equals 0 is what? Is a vertical asymptote. Okay. Let's remind you by the asymptotes. بالasymptotes نحن بنعرف is a limit as x tends to a number طلعت infinity minus or plus, then x equal to a is a vertical asymptote. If x tends to infinity minus or plus and the answer is a number, then y equal this number is a horizontal asymptote. And if x goes to infinity وطلع عنا جواب infinity, we have a possibility, okay, منا شو بس في possibility of an oblique asymptote. Okay, شو يعني oblique؟ يعني مثلا له equation y equal ax plus b، يعني منه horizontal ومنه vertical. So how do we check if a line of this equation is really an oblique asymptote ولا لا؟ بنروح بنجيب الليمت. نجيب الليمت ل f of x minus y. Okay. إذا طلع الجواب equal 0 we calculate it. إذا طلع الجواب 0 then هيدا line of equation y equal ax plus b بيكون هو oblique asymptote. Okay. هودي كل شيء عن الاسيمتوتس وعملنا لهم revision بأول السنة وهسه عملنا لهم recall again. Okay. Now for the other limit f of x minus x as x goes to plus infinity. Again f of x minus x هيدي فيها x طلعوا هي في كان already x ونحن عم نعمل minus x فراح يكنسلوا هول. اوكي وراح يطلع لنا بس الفراكشن. هيدي الفراكشن فبس نعوض plus infinity راح يطلع لنا infinity in the numerator and infinity in the denominator. This is an indeterminate form. أكيد we do not stop here. We have to find a value. Okay. The thing we can do here is we can split the numerator. We can split the fraction into two fractions. Okay, we can write it the same fraction. We can write it as ln x over x alone and 1 over x alone. ln x over x هيدا أخذناها property بالكتاب ويلي بده ما يحفظ البروبرتي فيه يعمل HR orbital rule بتصير بس نعمل derivative هاي بتصير 1 over x وهي بتصير 1 وبيرجع بيطلع لنا جواب لأنه إذا ما نعوض دغري راح يطلع لنا كمان indeterminate forms. okay. بس هيدي أخذناها رول إنه هي راح تطلع 0 and 1 over infinity هون محل x نحط infinity كمان يطلع لنا equal to 0. Okay, now we have to interpret this result. How do we interpret this result? مثل ما حكينا من شوي إذا نقصنا f of x minus y طلع الجواب 0 معناتها هيدا ال y is an oblique asymptote. Okay. يعني هون عندنا we can interpret two results. هون أول result إنه the line of equation y equal x. okay هيدي كأنها ال y. مين line of equation y equal x؟ هيدا اسمه d. given بالexercise إنه it is the line d. So we can deduce that d is an oblique asymptote for the curve of f, يعني for c. And what about the limit of f of x? Limit ل f of x as x goes to plus infinity. شو بده يطلع الجواب؟ أكيد بده يطلع الجواب كمان هون infinity. لأن نحن بنعرف بس يكون عنده oblique asymptote إذا ما طلع infinity بده يكون عنده horizontal asymptote. فالoblique asymptote إجباري plus infinity. وكمان فينا نشوفها بطريقة تانية. فينا نشوفها إنه الليمت ل f of x minus x is equal to 0 as x goes to plus infinity. فينا نوزع الليمت هون. okay as x goes to plus infinity minus limit ل x as x goes to plus infinity equal 0. إذا أخذنا هيدا الليمت لتاني مايل راح يصير positive. فراح يصير عندنا هيدا الليمت بيساوي هيدا الليمت. وهيدا أكيد واضح as x goes to plus infinity. هيدا راح يطلع plus infinity. فبتصير limit of f is equal to plus infinity. okay فهودي ال two interpretations لازم نكتبهم. okay now for part 6 they asked us to verify that f of k is equal to 2k minus 1 over k. okay what is k? k is the root of g. يعني recall that g of k is equal to 0. وال g of k كانت هي g of x كانت x squared plus ln x. so g of k is k squared plus ln k. وبنعرف انه هيدا الشيء بيساوي 0. okay بس اذا هيدا الشيء بيساوي 0 let's try to find f of k. f of k كمان بنعوض محل x k هيطلع لنا k minus this fraction. we do a common denominator. okay يعني multiply هون over k times k راح يصير عندنا k squared minus ln k minus 1. لا minus 1 دايما ننتبه لهم للساينز لأنه هاي الماينس للفراكشن is also to the 1. okay so now what can we do with ln k? okay how can we use this result? we can use this result to know that ln k is equal to what? is equal to minus k squared. I can take k squared to the other side. okay now if I put instead of ln k minus k squared, I have minus times minus, which is plus. So k squared plus k squared, I'll get 2k squared minus 1 over k. I can split the fraction. يعني هاي بتصير 2k squared over k minus 1 over k. k with one of the k's here cancel out. I'm left with 2k minus 1 over k, which is the needed answer. Okay, for part 7 now, verify that f prime is equal to g of x over x squared and set up the table of variation. Again, I remind you why f of x, it is this function. How do we find the derivative of this function? First, the derivative of x is trivially 1. Okay, now how can we find the derivative of this function over here? Okay, this is a fraction. So how do we find the derivative of a fraction? Okay, we have u over v, its derivative is u prime v minus v prime u over v squared. يعني بناخد هون u is equal to ln x plus 1. So the derivative is simply 1 over x. Then the derivative of 1 is 0. v is equal to x. So v prime is equal to 1. Okay, وعوضناهم هون. شو هي rule again? هي u prime v minus v prime u over v squared. Okay, After we find the derivative شوية simplification multiplication وهيك هون عملنا common denominator صار عندنا numerator هو x squared plus ln x which is g of x. Okay, over x squared أول شيء x squared is always positive. Okay, لأنه عليها power 2 وأصلا الx هي positive. فشو صارت الساين للf prime؟ How do you find the sign of f prime? The sign of f prime is the same as the sign of g. Okay, لأنه denominator positive it depends on the sign of the numerator. ونحن نعرف جبنا الساين للg فوق. جبنا الساين للg إنه it is negative before k and positive after k. So the function f is decreasing and increasing. Okay, I have now to find these values. At k also I know here that f of k is 2k minus 1 over k. This is the value I just found it above. Okay, and at plus infinity what happens at plus infinity؟ كمان هودي limits نحن جبناهم هاي الانتربريتيشن اللي عملناها من شوي. So as x goes to plus infinity هاي رح تطلع plus infinity as x tends to 0 كمان جبناها طلعت plus infinity. اوكي لك وين هون هودي الليمتس اثنيناتهم طلعوا plus infinity. اوكي بالبارت اللي بعده طلب منك calculate f of 1 and draw d and c. f of 1 simply substitute 1 instead of x and you'll get the answer 0. Okay, شو معناتها إذا ال f of 1 is equal to 0 شو معناتها؟ معناتها the curve c passes through what point? Through the point of abscissa أو coordinates 1 and 0. Okay, وهي البوينت أحسن ما نخليها in terms of k نحن بنعرف إنه ال k is somewhere between 0.6 and 0.7. Okay, so we will approximate it to 0.65. يعني إذا نحن بدنا نجيب 0.65 شو راح يطلع لنا الجواب؟ Okay, .65. You can calculate this on the calculator and you will get minus 0.24. Okay, so it's an approximation. It's not exactly like this, but it is an approximation. Now we have to draw D and C. To draw D, it's easy. It's the line of equation y equal x, and it is the first bisector. But how to draw a curve? To draw a curve, we have to go through these steps. First, we have to decide the domain of definition. Okay, and here it is known, it is 0 plus infinity. Then we have to draw the asymptotes and the tangents. Okay, we have no tangents in this exercise, so it's fine. Asymptotes, we have two asymptotes. The line of equation x equals 0 اللي هو ال y-axis, and the second line d اللي نحن already رسمناه اللي هو first bisector. Table of variation جبناها, derivative and the limits يعني بنعبي ال values عبيناهم كمان. And then the fourth step is to put the special points. يعني بنشوف أيمتى الكيرف بيعمل intersection مع ال x-axis, أيمتى بيعمل intersection مع ال y-axis, أو في points بيكونوا given. يعني مثلا in this exercise أعطانا إنه ال f of 1 is equal to 0. Okay, this is one of the points of the intersection with the x-axis. Okay, كيف بجيبهم يعني هودي points؟ كيف نعمل intersection مع ال x-axis؟ بنحل the equation f of x is equal to 0. والintersection with the y-axis كيف بنجيبها؟ بنعمل calculation لل f of 0. So in this exercise, domain of definition ببلش من الزيرو و open at 0. Okay, يعني أصلاً ما في عندنا f of 0. It does not intersect the y-axis. بتبلش دغري بعد ال y-axis, only on the positive, in the positive part. وحتى هيدا ال f of x equals 0 هون ال f of x الفانكشن كتير معقد. يعني نحن هاي ما بنعرف نحلها, ما بنعرف نجيب لها أجوبة, بس هني أعطونا one of the solutions اللي هي f of 1 equals 0. هسا بعد هيك بدنا نشوف relative position, وهيدا الشيء كمان جبناه أيمتى مثلا الكيرف is below the asymptote, أيمتى it is above the asymptote, and then we finally draw the curve. Okay, So let's go here. Here أول شيء بلشنا رسمنا اللاين. هيدا اللاين the first bisector يعني بيمرق ب 1 1 2 2 3 3 and so on. بيرجع حطينا البوينت 1 0 لأن احنا عارفين إنه راح يمرق بالبوينت 1 0 لاقي لأنه f of 1 is equal to 0. حطينا البوينت الثاني f of k كي نحن بنعرف هون اوكي هون نعرف إنه at k كمان at k راح يكون 2k minus 1 over k يعني here at 0.65 تقريبا راح يكون minus 0.24. اوكي so حطينا هاي البوينت as an approximation وهاي البوينت شو بها هي راح تكون المينيموم. لاحظنا هون هي اوطى بوينت راح الكيرف راح ينزل لعندها ويرجع يطلع. ورجعنا كمان نحن بنعرف البوينت هيدا من relative position. relative position جبناها هون. اوكي relative position بتقولنا انه من 0 لعند e to the power minus 1 كان c above وبعد e بعد 1 over e يعني e to the power minus 1 صار c below. فراح نحطها لهيدي البوينت 1 over e 1 over e كمان we will plot it. ليش حطينا 1 over e 1 over e؟ لأنه نحن بنعرف إنه هاي البوينت of intersection بين الكيرف and the first bisector. اوكي فبعد ما حطيناها هسه صار فينا نوصل هول البوينتس وهودي الاسيمتوتس الجرين 1 يلي هو الواي اكسس اوكي هيدا and the oblique asymptote. ونحن بنعرف إنه راح يكون at 0 راح يكون هون plus infinity راح ينزل through هودي البوينتس يوصل عند هاي المينيموم يمرق بهاي البوينت يطلع على البلس انفينيتي يصير لأنه هيدا اوبليج اسيمتوت راح يصير يمشي حده. okay ف something like this. Now when we draw the curve we will get this curve. okay فهيدا هو الكيرف of C بيكون. هيك بنكون خلصنا part 8 اللي هو draw وبعد في كم part إن شاء الله بنحلهم بالفيديو الثاني.